Okay.
Thanks a lot.
Uh-huh.
So we'll talk a little bit about options. We'll go through a couple examples on the binomial trees, and then next week I'll do a Black-Scholes example. So we'll try to focus at this point on just key parts of the book, and then let me know about the R analysis. Okay. And if you get stuck on any of the homeworks, I have the solutions manual, so you can check it. Don't get stuck, don't get frustrated, just move on, set it up, and then go back, and then I'll provide you with the solutions. Okay? All right. So in the first example, getting used to the option diagrams, when you go long call option, this is the profit, this is the stock price, moves, and then the exercise price. Okay, and that's going to be your exercise. So when you buy the long call, you're going to pay the premium, and then the stock price has to go up until you reach break even on the premium, and then you're in the money. When you write a call, or go short a call option, you're going to write, so you're going to receive the premium. Then as the price goes down, you're going to hit the break even, and then if the stock price keeps going, then you're going to be in the money. The put option, you're going to buy the put. Again, you're going to pay the premium. Then as the put option, as the share price falls, the put will be in the money. And then you can also write the put option too. When you're looking at option contracts, the expiration date, the longer until the expiration date, the higher the time value of the option. American options allow you to exercise at any time within the option period. European options only exercise at the end of the period. So because of that optionality, the American options will always have a higher value in most cases than European options. You're going to pay a premium when you go long the option contracts. When you buy the put or buy the call, you're going to receive the premium if you write the option contracts. The value of the option contract could be used, you can determine the value of the option using the Black-Scholes model, which I'll go over next week. And the value of the option is heavily influenced by the volatility in the underlying asset. So the more volatile the price is, the higher the option value. In optionality, the ability to exercise at any time during the option period. You can be at the money, which basically means that the price has moved enough to reach break even. You can be in the money, which means that the price has moved beyond the exercise price. So now you're in the money. And out of the money is the price hasn't moved enough to reach break even. So you're still basically underwater on your trades. Intrinsic value of the option contract is made up of time value and intrinsic value within the option. So the probability that you're going to be in the money. So it's not only time, but also the volatility. So the more volatility, the higher the probability that the option will be in the money. To compete against swap contracts in the over-the-counter market, the Chicago Board of Trade and the Chicago Mercantile Exchange have invented flexible options and binary options and credit event options and credit event binary options, and doom options. So we'll get into exotic options later on in the book. But these are the engineering and the new products that have been developed to compete and to take market share from the over-the-counter market. When stocks split, the prices of the stock are going to be reduced and the number of options are going to be increased. There's initial margin and maintenance margin, or option contract trades. Initial margin is what you're going to put up. The maintenance margin is the minimum amount of margin that you can have in the account, and once you go below the maintenance margin, you either have to close out your account or put up more money. Warrants are basically option contracts issued by corporations that allow you to exercise the call options, let's say, based off strike prices. And employees are issued warrants, just like they are issued stock grants and stock options. So stock employees will be granted stock options after a certain time period of vesting. The valuation methods to value the stock options use the traditional Black-Scholes methodology. So there's really no difference. But these are private options, and the option contracts are calculated based off of the Black-Scholes. Convertible bonds have an optionality to it also. You can, at some point, convert to the stock. Obviously, when the stock reaches a certain price, it makes sense to convert from the bond to the stock. And there's also a call provision on some of these bonds. So if you buy a callable corporate bond, at some point in time, if interest rates drop to a certain level, and the bond that you have is paying at a higher interest rate, the corporation is probably going to call the bonds. Again, the price of American options are usually higher than European options because of the optionality, the ability to exercise the option during the option period. The call option price, the maximum for the call option price is the current stock price minus the exercise price multiplied by E to the negative RT. The maximum for the put option is the exercise price times E to the negative R to the T minus the current stock price. Put call parity basically states that the call price and the put price, is it on?
Yeah. Just trying to turn it.
Oh, go for it.
Yeah, good.
Okay, thank you. Put call parity basically states that the price of the put, price of the call times the exercise price times E to the negative RT is equal to the put price plus the current stock price. The impact of dividends, you're going to subtract from the current price when the dividend is paid. It's basically the same equation, but again, you have to take into consideration, take out the dividends. And then for the put, you're going to add the dividend to the exercise price, minus the current stock price. There are different types of option strategies where you can, such as do a bull spread, which is you are going to buy a call and you're going to write a put in different time periods, for different time periods, different exercise time periods. So what it basically does is it reduces, because you're writing the call, it's going to reduce the amount of money that you put out, right? It's going to move back the exercise, or where the stock price needs to be after the first exercise price. And then the max that you can, the maximum that you can actually gain. So it truncates what you're trying to do as opposed to just a pure buy and a call option, which has limited upside. So it reduces the amount of out of pocket, but caps the in the money that you can be, the amount that you can be in the money. You can also do a bull spread on put options. You can buy a put, you can write a put, and then again, what it's going to do is it's going to cap the amount in which you can benefit from the put option. It's similar to a call option. So you're really writing to offset your total out-of-pocket premium, and then you're capping the amount of money that you can make. So the trade-off is smaller out-of-pocket total premium and capping the total money that you can make.
Well, there's two strike price.
Yeah, there's two time periods. In the yeah, so what you're doing is your same period, right, but two strike prices. So you're buying and writing the put, or buying or writing put, or buying or writing the call, but you're using two different strike prices. Two strike prices.
And which is the strike price for rights?
I don't know which one that is.
Because one is higher.
Yeah, so I would assume that this is the strike price for the call, and this is the strike price for writing the call. Writing the call and then buying the call. So you're gonna be in the money here, right? Because this is your break even. So the strike price would be here, and then when you're writing the call, here's your break even, right there. So you're not going right to the strike price, right? The strike price is back here, so you're gonna have to be more in the money in both of these trades to be able to get them to work. And then the put option, you're writing the put, and then you're buying the put. So here's your break even there, and your break even there. What it does is it truncates and then caps the amount that you can, the amount of in the money that you can be on these trades. So it basically sets a high and a low. Call options, you can also do a bull spread on the call options. You buy a call, you write a call. So you can see that here, this is going to be your break even, this is your break even here, and then this is the synthetic, this is what is created by writing the call and buying the call with different strike prices. So you still have to be in the money on the with the first strike price. You can also do a bear spread. These are actually, this is the bear spread. This is the bull spread. And you can also do a bear spread on using the put options. So you're going to buy a put, and you're going to write a put. So it pushes out the break even from here and here. Binomial trees. They're basically, you're calculating probabilities of the stock price being up to $22 in 3 months or being down to $18 in 3 months. The current stock price is $20. In 3 months, it could be as high as 22 or as low as 18. So you want to figure out what the call option price is. So the stock price is 20, stock price 20, or stock price 18. At $20, the option price is 1, and at 18, the option price is 0. So you can create a riskless portfolio. $22, the delta minus the one option, or the 18 minus 0. So 22 minus 1 is going to give you 18 delta. So 22 minus the 18 delta is going to give you the 4 delta between the 2 minus 1, plus 4, plus 1, 1/4. So the number of shares you want to go long the stock is 0.25. The number of options you want to go short is 1 call option. So if you want to calculate what the value of the portfolio would be in 3 months, it would be $22 times 0.25 minus 1, which is the option, equals 4.5, $4.05. Would be the value of the portfolio in 3 months. You can also figure out the value of the portfolio today, which would be the 4.5 to the E minus 0.12, which is the interest rate, times 0.25, because it's 3 months. This is going to give you $4.3670. If you want to figure out the value of the shares, it's 0.25 times 20, it's going to give you 5. 5 minus the 4.367, it's going to give you 0.663, which is going to give you the option value, the call option value. And this would be considered a riskless portfolio when you're going long the shares and then you're going short the call option. It's going to hedge off the risk. So the binomial trees, you have the current stock price and the option value. You have the probability that the stock will return the riskless rate. So the probability of the stock returning the riskless rate on the up, stock on the up, and the option on the up. 1 minus the probability is going to give you the probability of the stock on the downside and the option value on the downside. So you can figure out the value of the portfolio as we did by going long the shares and shorting the derivative. You can create a riskless portfolio through the share up, the delta minus the option contract value on the up, equals the stock value on the down and the option value or price on the down. The delta can be figured out by the option on the up minus the option on the down price divided by the price on the up and price on the down. So if I want to figure out the option value, I can take the price times the delta minus the price on the up delta minus the option value on the up times the E minus R to the T. So an example of a riskless portfolio or risk neutral scenario is we know that the current stock price is 20. The stock price on the up is $22. The option contract price is $1. When the stock price is 18, on the down, the option price is 0. So I can figure out first what the p-value is, the probability that the stock will return a riskless rate. So you take the $20 times the E to 0.12 times 0.25 equals 22 P plus 18, 1 minus P. So the p-value, if you solve for the p-value, is going to give you 0.6523. So we can take the 0.6523 times the $1 for the call option plus the 0.344, which is 1 minus the 0.6523 times the 0 price for the option, and we can multiply that by E minus 0.12 times 0.25 is going to give us the 0.633, which is going to be the value of the call option, and then you can multiply that by the number of contracts. So what you're doing really with the binomial trees is calculating the probabilities. First, having the stock value on the up, the price of the call option on the up, which you're going to be in the money, the stock price on the down, which is the value of the option is going to be 0, and then you can calculate the probability that the stock price is going to return the risk-free rate, and then you can calculate based on the interest rate and the time period times the probability times the option price plus the probability times the option price on the way down. It's going to give you the value of the option contract. Okay, any questions? So the Black-Scholes would be the next method that we would use to come up with the call option value. And that's what we'll do next week. Okay. Did you want to take pictures of that?
I already take.
Oh, did you? Okay.